So we are going to solve this differential equation, and the steps to solving a differential equation are these. You are going to separate your variables. You are going to integrate both sides with respect to the different variables, and then you will solve. So separate, integrate, and then solve. So when I say separate, what I mean is I have dy, I have a dx, and I have a y and an x. We're going to separate those so they are on different sides. Okay, so we want our y's to be on the left and we want our x's to be on the right. And you're always going to multiply the denominator to the right hand side. So we have dy is equal to yx dx. Okay, and then we can divide by y, and we get 1 over y dy is equal to x dx. So that's what I mean by separate your variables. You need to get the variables for this one on the left and the variables for this one on the right. If you have any other variables or any other constants, I would recommend you keep them on the right if possible. So try to just move the as little as possible to the left hand side. So we're just going to move the y to the to the left hand side. If I had y minus 1, I'd have to divide a y minus 1. But yeah, if you have any constants, like if there was like a 2 here, let's say it was 2yx, I would leave the 2 on the right hand side. So again, we're separating the variables. So keep your whatever this variable is, keep that on the right, and then the other one you're going to keep on the left. All right, separate. Now we're going to integrate both sides. And I am showing this as a different step, so my grader knows exactly what I'm doing here. The first thing I did is I separated. Now I am going to integrate. The integral of 1 over y dy is, of course, ln absolute value of y. Don't forget that the antiderivative of 1 over y is ln absolute value. Okay, absolute value, don't forget that. Now, technically, there's a plus c here. You'll see that I'm going to show you the plus c on the left-hand side just once, but for the most part, I don't use the plus c again. You're going to use the plus c on the right-hand side is generally where we have a plus c. So the antiderivative of x to the first is 1/2 x squared plus c. So this is the part, like I always keep a plus c on the right. And the reason that I always keep a plus c on the right is if I take a constant and I subtract a constant, what am I going to get? Another constant, right? A constant minus a different constant. These are two different constants. If I subtract them, I just get another constant. So normally I don't even show this step. I normally just jump right here. And I just write ln absolute value of y is equal to 1/2 x squared plus c. So again, it's kind of like when we first learned integrals, we had to put plus c for an antiderivative, and then we plugged in the bounds and we subtract. And then when you subtract with the bounds plugged in, the c's cancel. It's kind of the same thing here. Like when you find an antiderivative, technically you need a plus c everywhere you find an antiderivative. But since I have a plus c on both sides, once I subtract one of them, I end up with just plus c on the right-hand side. So go ahead and just keep your plus c on the right as long as you have a plus c. If you don't have a plus c, then you're going to get a lot of points taken off. So make sure you have your plus c on the right-hand side. All right, and then we're going to solve for y. So this is the solve part. So to undo ln, I'm going to do e to the both sides, right? So I'm going to do e to the ln y is equal to e to the 1/2 x squared plus c. Okay, well, e to the ln is going to cancel. I just get absolute value of y is equal to e to the 1/2 x squared plus c. Now, you'll notice that at this point, I have an absolute value and I have an e to the power. Well, isn't e always going to give me a positive number? So I can actually take away my absolute value symbols. Okay. And you have to wait until this point to plug in to take away your absolute value. So do not take away the absolute value until you get to something where like it's going to be positive, and then you're allowed to take it away. Okay. All right. Now I have e to the 1/2 x squared plus c. Now you'll remember, if I had this, I'm just going to remind you of some basic algebra skills. X squared times x cubed is x to the 5th. And the reason it's x to the 5th is it's x to the 2 plus 3. Likewise, if I have x to the 2 plus 3, I can separate that into x squared times x cubed. So we're actually going to do that here. We're going to separate this into e to the 1/2 x squared. And then instead of plus c, I'm going to multiply by e to the c. So again, if you have the same base and you are multiplying, you can add the exponents. And we're just doing this backwards. We're taking added exponents and we're just separating them. All right, and then lastly, e to the c. What is e to a constant? It's just a different constant, okay? So you'll notice that I'm using c as a placeholder for a constant. Now, at first I showed you like c sub 1 and c sub 2, but I am going to go ahead and just use c's from now on. So you can use like c sub 1, c sub 2, c sub 3, c sub 4 to represent different constants. But you are also allowed to just use c as a placeholder because c is just some constant. Now, does e to the c, like let's say c was 2, does e to the 2 change into 2 times? No, it doesn't. But e to the c, e to the second power, is a different constant. So this c as a number is not the same as this c. They are not the same c, but they are a c. So they are some constant. So I just want to point that out. Like we just use c as a placeholder for some constant. So if I have this c here, that is not the same thing as this c here. They are different constants, but they are both representative of a constant, okay? So you can go ahead and you can use c all the way through. Just know that it represents a constant, not necessarily the same constant. And then once you have it solved for y, you can go ahead and circle your answer. You're done.